Hi, welcome back to the Mintmac Games channel. My name is Tim McCarthy. In my previous videos, I've gone through all the basic pieces of Unity necessary to actually create a very simple game. And in this video, that's exactly what we're going to do. I'm going to call this game Spaceship Blaster. And basically, it's just going to have spaceships that go across the screen and we're going to blast them. Now, it takes a fair amount of script in order to get the basic fundamental pieces of the game going. And instead of sitting watching me type all that script, I've written most of it ahead of time. But I am going to be going through each line piece by piece and explain what it's doing and why it's doing it. So, in this part one, we're basically going to focus on the game mechanics, just getting all the pieces working. The second video will cover actually creating some spaceships in Blender and bringing them in, and we're going to just go from there. So, why don't we put our coding glasses on and let's get started. Before diving in to build our first game, I want to go over 4 questions that I always ask myself before I write any code. First question: what action do you want to do? Followed by, what data do you need to do it? Thirdly, and most importantly, is where are you going to get that data, which can be kind of tricky in some cases. And fourth, what will trigger the action? There's lots of different things that can trigger an action in a game, whether it's the user presses the mouse button, moves the mouse, presses a keyboard key, timer expires, or a variety of other things. So as we go through the scripts, I'll be asking myself these questions and answering them, and then writing some code to make that happen. So now that we've got that out of the way, let's get going and write some code. All right, so what we want to do is start our first actual game. So what this game is going to be, I'm going to call it Spaceship Blaster. So what I did is started from where we left off with tutorial number 4, and I've created a scene called Spaceship Blaster. And what I've done is I have taken our blue-white grid that we had in our test platform and I've added it to this scene. Remember that if I go back to this test platform, this is where we left our test platform in tutorial 4. So we had all these cubes, and we were creating the controller. We had our plane with the blue-white grid. So as soon as I made a new scene called Spaceship Blaster, it was empty. It had a camera and a light. What I did is I added a plane to it. And I added these spaceships, but I'll go over that in a little bit. But I added this blue plane as a starting point to work with. Then what I did is I thought, what do I want my game to be? So this is going to be a very simple game. And what I'm going to have is I'm going to have our little controller across the bottom, and it's going to be firing projectiles up, but I have to shoot at something. So what I'm going to have is I'm going to have these spaceships going back and forth across for me to fire my projectile at. And what I want is I want them to be in specific, I'll call them lanes. So I want 6 lanes. I want the first one to be about right here, about midpoint of my plane. Remember, I'm at firing from the bottom. So my first one's going to be here, my second one here, my third one here, 4th, 5th, and 6th. So I have 6 lanes. And I want my spaceships to either go right to left or left to right. So that's what I want to do. And I'm going to have to figure out how to position my spaceships in order to line up with my lanes. So that's some data I'm going to need. I'm going to need to know where to start my spaceships from, and I'm going to start them from either the right edge or the left edge. And then I need to know the Z value how far up the plane that I want to position them, and then which direction that I want to go. And there's some other things I need to worry about. Like, what if a spaceship is going right to left and I decide to put a spaceship starting from left to right? They're going to collide in the middle. So I can't have that. So what I'm going to need is I need to determine if there's already somebody in my lane going in the opposite direction. All right. So I also need to know what is going to trigger the creation of my spaceship. And in this case, what I'm going to do is I'm going to base that on a timer. And so I'm going to need to know how fast do I want my spaceships to come out. So that's another piece of data I need to know. And in this case, I am going to get it from the scene itself. And so you'll see how I do that. So that's kind of an overview of what my Spaceship Blaster is going to be. I also want to be able to keep some score, right? So every time I hit a ship, I want to add some points to some kind of scoreboard. And we'll eventually get to a scoreboard, but I need to kind of worry about that as I'm setting up my game. So let's dig into the main script that I have. That's the biggest, most complicated. And I'm not going to sit and type out the whole script. It took me a couple hours to, type it up, get it all working, debug it. And I don't want to make a 3-hour long video just watching me go through the debugging process of one script. But what I'm going to do is I'm going to open the script in Visual Studio as usual. Spaceship Launcher here. And I'm going to walk through all the code, kind of explaining what it's doing so you can kind of understand how I got all of this working. So we start with our top of our script. Every script starts with a name, right? A class name, and it's based on this mono behavior if I want it to operate within Unity. And my first two items are data that I'm going to get from the Unity editor. If you remember from my previous tutorials that if you use this serialized field, that specifies that it's going to show us a UI element for this script in the UI, and I can set it to whatever I want. So the first thing I want to do is I want to get how many spaceships per minute. So you can imagine that maybe I am going to set up different levels, and different levels I want the spaceships to come out at a different rate. Maybe the higher the level, the faster the rate, or the slower the rate, or whatever it is I happen to want to make that level more challenging. But in this case, I'm going to specify how many spaceships I want to come out every minute. I could have specified it seconds between spaceships or some other value, but in this case, spaceships per minute, and I'll default it to 1. The other thing I need to know is I need to know game objects. I need to be able to get the game object for the spaceships themselves. And in this case, I'm going to use a new variable type called a list. So in this case, I can have any number of spaceships. So when I'm setting up my scene, I can set it up for just one spaceship type. I can set it up for 100 spaceships types. It's up to me. So that's why a list is any number of spaceships, and we'll see what that looks like in the UI. Then I'm going to make some member variables because there's variables that I need to know across a couple of our different functions. And any of those variables are called member variables, and they're up top. And I always start them with an underscore. It's kind of a standard, so I know that they're a member variable. And I need to know how much time has gone by since I last launched a ship. And I'll default that to 0. I need to know the actual launch ship time, and you'll see where I use that. And this is probably the more complicated part, is I have a variable called all lanes. So I need to keep track of what spaceships are in each lane. So I have 6 lanes, and I can have any number of spaceships in each lane. So I make a list of lanes, and then inside each list of lanes, I have a list of game objects. So I can have any number of game objects inside of any number of lanes. And I'll call that all lanes. So when my script starts, what I'm going to do is I'm going to compute a launch ship time. This is the number of seconds between each time I launch a ship. And I'll take my ships per minute, and I'll take 60 divided by that. So that will give me the number of seconds between each ship launch. Then what I need to do is I need to create all my lanes. Until I create something, this is just a reference, right? I haven't created anything. I've just defined what all lanes are. And so what I'll do is I'm going to create a new list of game objects and add it to my lanes. And I'll do that 6 times. 1, 2, 3, 4, 5, 6. So I have 6 lanes that I've created, and each lane is currently empty because I haven't launched any ships yet. So I'm all set up. I know how many seconds between each time I need to launch a ship, and I have all my lanes defined, and they're all empty. So what's going to happen is every time I update, what I'm going to do is I'm going to add the total number of time elapsed since I last got an update, and I'm going to add that to time since last ship. So this is going to start out 0, and it's going to increment, and I'm going to keep incrementing it until it's greater than my launch ship time, because that says it's time to launch another ship. And if it's time to launch another ship, I'm going to call a function that I wrote called launch ship. So where am I going to launch the ship? And what type of ship is it? I am not sure yet. I need to figure out where I'm going to get that data from. And then what I'm going to do is I'm going to reset my counter back to 0. Because if I don't, the next time I hit an update, it'll be greater again, and I'll launch a lot of ships really fast, which is a very common mistake to make that I make all the time, and it's kind of fun to watch them all pile up. But we don't want that, so we're going to set that back to 0. All right, now comes the fun part. We need to launch a ship. So there's lots of things I need to compute in order to launch a ship. I need to know the distance, right? How far away I need to create it. This is in the Z direction. I need to figure out what lane I want to launch it in. So what I'm going to do in this case, I just want it to be a random lane. I want my ships to be fairly random as far as which lane they launch in and how far away they're going to be from me. So what I'm going to do is I'm going to compute a lane index. And what I'm going to do is I'm going to use this random range. So this is going to pick a number between 0 and 50. And I'm going to take that number and I am going to round it to an integer, because random numbers are always floats. They're called floats. So it's going to pick some number between 0 and 50, and I'm going to divide it by 10 after rounding it to an int. So that's going to give me an index. And the thing is that if this is an integer, one thing you have to remember is an integer, say that number was 15. 15 divided by 10 is going to be 1.5. But this is a float, so it's going to truncate it. Essentially what I'm going to do, this function right here is going to give me a number between 0 and 5. Because that's what I want, a random number between 0 and 5. And this is the best way to do it. So then I want a ship index. I want to pick randomly which ship that I want. And this is a little trickier, and it took me a while to figure out why my ships weren't coming out evenly is I want basically a number 0, 1, or 2. And if I pick a number between 0 and 1 and it truncates it, any number between 0 and 1 is going to be 0. Any number between 1 and 2 is going to be 1. And 2 and 3 is going to be 3. And what ends up happening is, and it's kind of hard to explain here without a long explanation, but really what I want to do is I want to pick a number between negative 0.5 and 1.5 and then round that to the nearest number. The problem is rounding, remember if it's greater than 0.5, it's going to round up. And if any number between 0 and 0.5 is going to go to 0, 0.5 to 1 is going to round up to 1. And so then you don't hardly get any numbers of 0. So this equation right here is going to give me a even number between 0, 1, or 2. So that's going to be my ship index. So next, I am going to pick a random number between 0 and 1. Yes, I'm just going to pick a random value. Random value, as you can see, returns a random float between 0 and 1. And so if that random value is greater than 0.5, I'm going to go from right to left. Otherwise, I'm going to go from left to right. So here I'm going to have a 50-50 chance of coming out from the right or coming out from the left. All right. So the first thing I need to do is find a lane in order to be added to. And you might say, well, I have a lane index. I already found my lane. But the problem is I want to really make sure that lane is valid. Because remember, if there's somebody else in my lane coming the opposite direction, I'm going to crash into them. So I can't just blindly add myself to a lane. So we're going to go at that. I'll go over that in a minute. But assuming we found a lane and there's nobody in it going the opposite direction, I'm good to go. What it's going to do is it is going to add a ship to that lane. So my distance away, my z distance, is going to be my lane index times 10. So basically, remember the center point of my grid is actually at 0. I am sitting at negative 50 where my controller is. So 0 is going to be the middle point of my grid. And so if lane index is 0, it's going to be 0. If it's 1, it's going to be 10, 2, 20, and so on. So in this way, each lane is going to be 10 meters apart. Then I'm going to instantiate a new game object, and we went over that in some of the previous tutorials. We are going to grab our spaceships. Remember the list of spaceships. And I'm going to use my random ship index. And then I'm going to position it at x equals 50, which is the right side, y equals 1, because it's going to be sitting right above the surface, and my distance away that I calculated right up here is going to be my z distance, and then of course my identity rotation. Then what I'm going to do is I'm going to add my ship to my lanes given the lane index. So this is going to add that. So if someone else comes and tries to use this lane in the wrong direction, they'll know to avoid me. Then what I'm going to do is I'm going to set the speed, right? I need to get this ship moving. But what speed am I going to use? Well, what I did, and we'll see this when I show you the ships, is that I actually added a script to my ship. And I gave it a variable. And I made that variable public. So where am I going to get the speed of this ship? Is I want to get it from the ship itself. But my script isn't attached to the ship. So how am I going to access that ship? What I can do is I can get the component and then I give it the name of the script. So this gets me access to the ship's script component, and then I can access its public variable. And if we pop over really quick, actually I can show you the spaceship controller. And you can see there's a public variable here called speed. I also had a public variable called points, and so what I can do is I can attach the number of points if I hit the ship. But in this case, we're accessing the speed. So the speed needs to be set for that ship. My spaceship launcher can access that through the spaceship controller and access the speed. Then what I want to do is I want to get the component for rigid body and set its velocity. And we did this before for the projectile. And I'm going to use the speed and I'm going to multiply it by -1 because I want this to go from right to left. So I want it to move from the positive direction to the negative direction. Then what I'm going to do is I am going to multiply the points that the ship gets by its distance, because the further away the ship is, the harder it is to hit. So I figure, why not give it more points every time I hit it? The closer ships are easier to hit, so they should get less points. So I'm going to multiply the points by the distance it is away times the speed. So the faster the ship is moving and the further it is away, the more points it's worth. All right, so basically this else statement, it's doing exactly the opposite. It's going to start in the -50 position, and it is going to move in the positive direction. For the velocity is just going to be speed. And it's also going to add it to the lane. So it's either going to move one direction or another. All right. So now let's look at this find lane function. It's going to take the lane index. This is the index I want to use. It needs to know, am I going right to left or left to right? So I pass a Boolean in to tell me that. And then I'm going to get the speed that I want to go at. And we'll see why I need the speed in a minute. So a lot of times I like to use a variable return value because it's going to return the index that it found. And if you look at the comments that I wrote, the lane index to use will be -1 if no lanes available. So maybe, for example, what if all the lanes have something moving from left to right and I want to move right to left? There is a possibility that none of the lanes are available. And if there's no lanes available, I'm going to return -1. And you can see in this case, if lane index is -1, it's not going to add a ship. So I'm just going to skip the lane. So there just won't be a ship launched at that time interval if there's no lanes available. It doesn't happen a lot. And this is the easiest way to handle that. So what I have is I have a loop count, because if I'm looping through all the lanes, I might start at lane index 3, go to 4 to 5. I want to loop back to lane 0, 1, and 2 before giving up. So what I do is I created this while loop. While loops are kind of dangerous, and I ran into this when I was debugging this, is that while loops can lead to an infinite loop. And an infinite loop means if the condition is never true, meaning a found lane is never true, this is going to loop forever. And I found out the hard way that if this loops forever and I get an infinite loop, the whole Unity executable will lock up. And if you've ever programmed enough times, this happens occasionally in programs. And that is why Windows allows you, I'm on a Windows system, to Control-Alt-Delete, launch the task manager, and actually end the process by hand, because that's the only way to kill the process if you're in an infinite loop. And you can lose data. It's one reason why to keep saving your project work as you go along, because if you infinite loop and you have to kill the process, you're not going to be able to save your project. So, tip when debugging while loops. In this case, it's a handy thing because I want to loop until I found a lane. So if I come in here and if my lane that I want to check if the count is greater than 0, somebody's in the lane. But if not, well, that's easy. Found lane is true. Yep, you're good to go. Lane's empty. Return the same index that came in, and I'm all set. But if there is somebody in the lane, then it gets complicated, and there's this big, gnarly if statement here. So what is this doing? Well, what it's doing is it says if the first person in the lane, everybody in the lane has to be moving into the same direction by definition, because this function is making sure of that. So if the first item, if its velocity is less than 0, meaning it's moving from right to left, and my object is moving right to left, then I'm okay. Or if the velocity is moving left to right, meaning it's moving in the positive direction, and I'm not moving right to left, meaning I am moving left to right, then I'm also okay. So if either or of these conditions are true, I'm good to go, and found lane is true. But what's this last item? I also have to make sure that the speed that the game object is moving in the lane is not slower than me. Because if I have someone slower, remember these ships can move at different speeds, I could possibly catch up to it and crash into the back of it. And I also don't want that to happen. So I wrote this function isValidSpeed, and I pass in the speed. Remember, I pass in the speed of the object that I want to check. And I want to check all of the speed of all the objects in that. And in this case, I could have someone, say, at the lead going faster and someone behind them going slower. So I need to check all of the ships in that lane to make sure that nobody is slower than I am. And if the speed is also valid, then I'm good to go. Otherwise, this is a bad lane. So what am I going to do? I'm going to increase the lane index, go to the next lane, and if the lane index is greater than 5, meaning I've run out of lanes, I'm going to set it back to 0. If loop count is 0, meaning I haven't already looped around once. And in this case, that's true. So my lane index goes back to 0. My loop count goes to 1. If I've already looped around once, then I've run out of lanes. And I'm going to set lane index to -1, and I'm going to set found lane to true. So one way or the other, a good lane, because all these are true, the lane is empty, so that's true, or I've run out of lanes to check. Found lane is true, but lane index is going to be -1. So this isValidSpeed, basically it's going to pass in the lane again, and the speed, and it's going to loop through this for each, loops through each object in lane. So I want a game object, and it's going to loop through all of the game objects in the lane, and it's going to check the absolute value of the velocity of the game object moving in the lane, and it's going to make sure it's less than speed. And I need it to be the absolute value because, remember, some of these could be negative. And -50 is less than -20, but they just happen to be moving right to left. That's why they're negative. And negative, if I take the absolute value, it's always going to be checking the actual speed and not take direction into account. So I take the absolute value, and if everybody's good to go, it actually starts out true. But if anybody is slower, basically, that's what this is doing. If any velocity is slower than speed, then it is not valid, and it's going to return false. So the last function here is important because what's going to happen when a ship reaches the edge and it wants to destroy itself? It needs to be removed from the lane. So how am I going to get that information? The data I need is an object, a game object. One of the ships is about to be destroyed. how am I going to have that game object tell me that it needs to be destroyed so I can remove it from the lane? And what I did is I created this static function. So a static function means that of all the instances that I have of this class, there's one and only one, in this case, function, and it can only operate on static variables. That means there's one and only one variable across all of the instances. Now in this case, I only have one instance of Spaceship Launcher, so I really don't have to worry about that. And in this case, that's what I want. I only have one set of lanes, and I want them operated on by many different spaceship objects. And so I create this static function. And the nice thing about static functions is I can call them without an instance, meaning from anywhere inside my program, I can call this function. And if we look at our spaceship controller, so our spaceship controller has only one job. If the position is less than -60 or greater than 60, it's going to destroy itself. That's what this destroy is. But before it destroys itself, it's going to take Spaceship Launcher. I just use the name of the class for a static variable, or in this case, a static function. And then I can call that static function about to destroy ship. And then I can pass myself as the parameter. So now in my Spaceship Launcher, I get the object to remove, and then I loop through all the lanes, and I'm going to remove that object from any lane that it happens to be in. By definition, it'll only be one. I don't really know which lane it's in, so I just loop through all of them and remove that object. All right. So that was quite a bit to go through, but I wanted to go through what all this code is doing because it's important to understand as you start to try to write your own scripts. And this is the main function. So now what we need is we need to create an object to attach that to. So I'm going to create empty, call this Spaceship Launcher. And I'm going to add our script that we just went through, which is called Spaceship Launcher. You'll notice as soon as I add that, I get the exposed variables. My launcher, my ships per minute, I'm going to make 45. And you'll notice my list. My list is currently empty, and I have these two controls. And so what I'm going to do is I'm going to add 3 of them. I'm going to come over to my spaceships. So what are my spaceships? I'll show them on the screen. What I've done is I've just created 3 different size cubes with different colors. So I have a big spaceship, and that's going to have our box collider. And it is going to have a rigid body. And I turned off gravity, and I made it white. And I have my spaceship controller, and I gave it a speed of 10 meters per second, and worth 10 points. Then my medium one, I set up, that's yellow, and I gave it a speed of 20 and 20 points. And my small one, I made red, and I made it a speed of 30 and 30 points. So my red one's going to be moving 3 times faster than my white, and my yellow is going to be moving twice as fast as my white. So I'll have different spaceships going in different directions, moving different speeds. So what I'm going to do is I'm going to click on my Spaceship Launcher, and I'm going to grab my ships and drag them into the 3 slots I made for my list. So now my list of ships are going to be these 3 game objects. So it's going to randomly pick one of these 3 game objects and launch it at 45 ships per minute. We'll select this again, unselect this to hide this. And then I'm going to run. So what we have is, you'll notice that things are lining up on our exact lanes. This is lane 0, 1, 2, 3, 4, and 5. I have nobody's moving, nobody's crashing into each other. And you'll notice that this white one could be in this lane because the red one was moving faster than it. What tends to happen over time is that if you launch too many ships too fast, the white ones end up clogging up all the lanes. See, nobody can use these 3 lanes. This little red guy couldn't do in those 3 lanes. And so sometimes you can get to a situation where you can get lots and lots of lanes with slower items, but that really comes into gameplay. You know, it takes a lot of trial and error to make a game actually useful and fun to play and challenging. So we're going to stop this. And the last thing we're going to do, and I know it's getting a little long, but what I want to do is I want to add back my blaster controller that we worked on the last tutorial. So I'm going to create another empty one. Call it blaster controller. And as you remember, we made a script called my controller. I should have called it something more descriptive, and I do this. It's like my controller. Not very descriptive. It's pretty generic, and it's not very useful, but we're going to leave it for now. And my projectile is going to be this missile. My blaster is going to be blaster. Now let's run. I'm going to move back and forth when I click. You're going to see it collided with each one of our little spaceships. What I'm going to do, remember, this is our scene view overview, and it's helpful for debugging, and I use it to see exactly my positions. Remember, we have our white grid. Each one of these is 1 meter by 1 meter. So we have 10 of these, so I could make sure that all my items are lined up. But when I first started doing this, it took a bit of debugging to get everybody to line up correctly and all the math to work out right. So that was very helpful. But what I've done is my game view, I'll drag it over here. I had it on my other screen, is I've set my camera to kind of be back behind and looking down our grid. So we get a kind of a 3D view of our game. And now let's run this. And now we can see in 3D our little guys blast off into space as we collide with them. No points are being calculated. In fact, my collisions aren't even being computed. We're just letting the physics engine do its thing. These guys have no gravity, which is why they kind of... Oops. I just clicked on the wrong window. That's why they're flying off into space. Kind of fun. We're probably not going to want to have that. Whoa! There's one flying at me. But it can be kind of fun. The problem is that you'll notice that some of my lanes are getting empty because as they fly off into space, they're never reaching the edge of my plane, and so they're never calling to have themselves removed from the lane. So that's a problem, but that is a problem for another day. We've got through a lot. Kind of made the fun start of a game to blast our ships. Not very interesting ships, but we'll take care of that. We'll take care of that in the next tutorial. So stay tuned. I'll be adding another tutorial where we'll be creating some actual game ships in Blender and bringing them in, adding some more interesting backgrounds, and make it look a little bit more like a game. Thanks for watching, and stay tuned for the next step in our game development. And as always, if you like this video, give it a thumbs up. Tell your friends. Hopefully you found it useful. Thanks.